we had messed up, right? We were so good at building these things really quickly and making sure that they demoed and that we could test them with people and all this. And here we had one of our first ones that we just failed as an engineering organization, right? And so when I got back, we took a trip. We packed the car, we went to Muir Woods, and we went on a hike. And we just sat there and walked around in the woods trying to figure out why we had failed so badly here. And we came to a bunch of conclusions. One was we had this really interesting way of working, but we let that way of working dictate our decisions. We let that way of working convince us that what we needed to do was just get it done as opposed to doing the right thing, taking a second, making sure we're making the right choices and moving on. And that cost us pretty dearly. We built a thing that was just full of bugs because we didn't slow down just a little bit, which would have ultimately actually sped us up. And it was, in this point, we ended up with a number, it was 4 different things that we had decided, vowed to be true. But one of the big ones was, this was the last time the demo breaks. And in order to meet that criteria, you have to change the way you work a little bit. So we got back, and we started to think about, okay, what are we going to do next? We built this interesting thing, but it was actually a nightmare to use, despite the fact that it was kind of cool. And we kept drawing these diagrams on the board that look a lot like entity relationship diagrams. And we asked, well, could we actually just make programming be entity relationship diagrams? And so we looked at some of the literature on that, and we threw together a version of Eve. This was the first one we publicly released. We called this version 0. And we called it that because it wasn't going to be programming. We knew that based on some things we had figured out. But it was actually useful. And it was a really interesting way of visually querying things where what you were building was the structure of the thing you wanted, and it went and found it. So if you asked for the triangle query, it looked like a triangle. And this was actually data log again. So this was doing inferencing and stuff like that. But it was pretty hard to imagine this scaling up to full, real programs. That being said, when we released this, people were pretty excited about it. We got a big bump in sort of people following along at that point. And along with the release of this, we also released our bibliography, which at the time, remember, I had never read an academic paper before. When we released this, our bibliography was 200 to 300 papers. It was about 1.5 years and all that. We got pretty good at reading stuff, yay! And amazingly enough, a lot of those things really changed the way we thought about stuff, and it really, this was a very important thing. I cannot overstate how much we got out of the amazing research people like yourselves do. But unfortunately, despite the excitement we had gotten, company land had issues again, which is that visas suck. So Jamie was here from the UK. We had him on this weird J1 visa, which is this trainee thing that we managed to get him. And we were trying to get him an O1 visa so that he could stay in the country and continue working with us. But his application got provisionally rejected, and it was this weird, crazy thing, and which really sucks because it took us several months to put together this O1 packet. Robert, my co-founder, that's basically all he did for quite a while. Yay, our immigration system. Unfortunately, the way things worked out, we found out that it didn't work very well when we worked remote with people, so Jamie had to leave us. So our merry band was down to 4 again. It was at this point we decided to do something somewhat unconventional in industry, at least, which was okay, we built all these different things, we're in a kind of a strange place, right? We're coming off that big failure. Let's all sit down and let every one of us go build our version of Eve. It doesn't have to look anything like anything we've ever done. It doesn't have to take into account anything that we have ever looked at. It is your version. And so each person in the company went off and went and built their own thing. And I won't go through all of them, but there was some really cool stuff that came out of this. And the goal was that at the end of a month, so this was a month-long thing, we would have 4 different versions instead of 1 version that was maybe a little bit more complete. But we would have tested more of the space and maybe helped explore a couple of ideas. And we had lots of ideas, we just didn't know which one to follow. And so Corey built this really cool version, which we eventually called Grid Eve, which was very much an Excel-like thing. except it had much more of this data loggy kind of stuff in it and could do more sophisticated things where there's real-time data in it, there was actually UI, and this was all hierarchical, and you had a really neat story behind it. I ended up building a thing that we eventually called CardWiki, which was this idea that, hey, what if we just had wikis, and that like programming was just asking questions over wikis, right? Because if you think about what Datalog fundamentally is, it's a query language, right? It's not an imperative language. So, okay, well, you can ask queries in English, right? And then maybe you can do something with the results, and that's programming. It turned out this one was pretty interesting, this version of the thing. And we cleaned it up a bit and started showing it to people and passing it around. And it eventually became the thing that I showed in a talk at Berkeley. And that talk was called In Search of Tomorrow, which if you want a deeper dive on a lot of the prototypes I'm showing here, this talk was actually walking through them and telling you all the various things we had learned about this and what was good about them and what was bad.
Is it recorded?
It is. Yeah, if you look for In Search of Tomorrow and type Chris Granger, you'll find it. But yeah, so we had done that, and what was really neat about that version of Eve was that was the first version when we showed it to people. They were like, I really want that. Yeah, this was one of the times when people immediately understood it, and it was a thing that they could see value in directly. And so when 2016 rolled around, we started to try and develop that idea a little bit more, because we found out that the CardWiki thing where you were writing a bunch of prose, people didn't actually like writing a bunch of prose very much. That's not a thing that we do very often. So we tried to make it a little bit more structured, and we put it in much stricter card-like things. And we released this one publicly, so people got to play with this. A fair number of people actually spent a surprising amount of time playing with this, despite how complete it was. We called this one Planet Eve because the demo we had was just full of planets. And it was around this time that we realized, somewhat unsurprisingly, that there were some pretty serious problems with doing natural language processing stuff. We had originally come up with this system to use graphs and term rewriting to actually do the NLP, which turned out to be much, much better than the thing we put into this, which is what you were supposed to do. Statistical NLP, I think, is an incredibly hard, unsolved problem. But the other thing actually worked really, really well. Unfortunately, we made the mistake of doing what the industry told us to do, and it wasn't as good as it should have been. And so we started to look at ways we could potentially fix the problems with NLP, right? And we tried to formalize it a little bit and remove some of the ambiguities. We came up with all these crazy ways of doing things. But we found out that once we started doing this, the naturalness of it fell away. It wasn't really natural anymore. The magic wasn't there. And this was kind of just like, well, maybe if we're going to do something like this, we might as well just make it look like Excel. This wasn't really any better than what we had done before. So back to the drawing board. And we came up with this big list of things that we were going to go try and do. And we're like, okay, we don't quite yet know how to do that part. But what we do know is that this data log thing really is working. Let's see if we can make something that maybe we could use, not necessarily grandma could use, or even the guy in accounting could use. And so we took this big list of things and started building out a runtime, and we added a textual syntax to it again, and we spent a bunch of time testing this out before we built anything and making sure that this was like an accessible thing, and had a bunch of really neat properties about it. You can go read about them online. But that eventually became what we released, which was called, this was version 0.2 of Eve. And I'm not going to talk about this too much because there's a lot to talk about in this particular thing. We actually went back and replaced our website with the one when we released this, so you can go read the long essay we wrote about all the cool stuff in here. But what I wanted to tell you a little bit about was this actually worked. People got really, really excited about this. So in the first week after we had released this, we had gotten just shy of 100,000 people to the site. And we were always pretty good at generating excitement. That was a thing that just we managed to be pretty decent at. I think people really wanted to believe that there actually was something better out there. And so you might think, oh, we were super excited, right? 112,000 users in the first month or whatever. And we actually had a really great conversion rate on this too. Of the users who came to the site, 30% went on to play with it, which is like 3 or 4 times a really great conversion rate. However, This is one of the things, you're here to hear about what happened behind the scenes. This is another big, big failure for us. One of the things we never talked about was how this came to be. So this was the version of Eve we worked on the longest in a single stint. And we had sort of split things up where some people were working on the UI, some people were working on the runtime. And it sort of became clear about 4 weeks before we had already stated we were going to launch this thing that the runtime wasn't going to come together at all. It just wasn't working. It was bug after bug after bug. It didn't really fit with what we needed. It wasn't fast enough. It was a pretty rough time. And so at this point, I made a very tough executive decision, which was, okay, the only way I know how to fix this, given the amount of time we have left, we had already told people we were launching then, you can't take it back from TechCrunch, was I know enough to write the runtime by myself. I don't know if I'm going to get it done in time. We only got 4 weeks, but I'm going to try. And so I took it over and rewrote the whole thing from scratch in 2 weeks. This was a big, big blow to all of us because we were a team who were good at what we do and we had failed pretty badly. And so despite the fact that our launch went really, really well, this took us a while to recover from. And looking back on it, we started to try and understand. We got around the table, right? We're like, okay, what in the world just happened? How did we get here again? This felt very much like what we saw at the Joy of Coding, but we weren't making the mistakes we were back then. So what happened? And it wasn't until I read this later, which this is Tony Hoare's Turing Award speech, which is great. You should go read it. But he actually knew exactly what happened back in 1981. He says, you know what went wrong? You let your programmers do things you yourself do not understand. And it made me realize that both in the Joy of Coding and in this case, the 2 times we really failed to produce something the way that lived up to our own standards were both times where no one in the company understood the whole thing. Right? It was that we had let things go off the rails, and we could have known very early on, if everyone had understood the entire system, that it was going off the rails, that it wasn't coming together, that things were being misunderstood. And this was on me, because I thought what we could do was really strictly sort of divide things up and let people go do their thing. But the reality is, given what we were doing and how tightly integrated it all had to be, that just wasn't realistic. We had to make sure we understood it. And so this became our mantra from then on out. We must understand the whole system. I would like to point out that this is basically incompatible with using open source software. So it took us a while to recover, but we knew what to do. So this thing was actually working. It was by far the most successful version of Eve we'd ever had. We were able to do really cool and crazy stuff with it. One of the problems we had was that I had built that runtime in 2 weeks. It was not going to be the fastest thing in the world, although it was based on really great research by Hung, right, on a thing called generic join. And so what we knew we needed to do was find a way to make it faster. And we did a bunch of things to try and do that. Pretty early on, we're like, okay, well, we built several versions of things in Rust. It's way, way faster than JavaScript is for some of these kinds of things. We need to rebuild some of this stuff in Rust. And we took some really great work from one of my favorite people in academia, Frank McSherry, who I basically think is a troll in the academic world. He basically goes around and shows that people, the work that people are doing can't beat his laptop, even though they're using 130 node InfiniBand clusters, right? Anyways, he did some amazing, amazing work at MSR years ago on this thing called differential data flow, which is about trying to make computations incremental. And we took that and the work I mentioned from Hung about a crazy join algorithm called generic join, and we built a Rust runtime out of this, and it was starting to get pretty fast. Unfortunately, these things are, when you put them together, which is a pretty weird thing to do, but when we did put them together, they were completely unintuitive when you were actually implementing them. Like the way differential data flow works has some just off-the-wall implications. And it took us, remember, we're used to doing things in, like, complete things in a month. It took us 2 or 3 weeks just to get the implementation of distinct correct in this system. And it wasn't until Josh drew these crazy diagrams on the board that we sort of finally came to understand what in the world was going on. But we did eventually make it through. And it worked. That's the old 0.2, and this is the Rust version. So this is a logic programming language running games at 60 frames a second. That was pretty cool. That was the thing I'm pretty sure we'd never seen before. And we started looking into, how well did we actually do here? Like, what did we manage to build? And there's this great paper by Chris Ray's group out of Stanford that went through and looked at the state of the art in RDF processing at the time. It did a bunch of benchmarks, and they had created this new system called empty-headed that was just blowing everybody out of the water. And so we benched ourselves against that. And it turned out that we had managed to accidentally make one of the fastest triples databases in the world. We were beating the best in the paper, the state of the art, by 500x. So it goes to show, there's a lot of room for improvement out there in the industry. Now, all that being said, this was super cool and this was awesome and we had managed to make something great. The reality is a really, really fast database is still a really, really slow programming language. So we could put 2,000 balls on the screen. In Rust, I could put 4 million. Okay. Still not really there yet, not for general purpose programming. So it's time for another hike. So we rented a cabin up in the woods and we stayed there for a week and we just worked and worked and worked. And eventually what we put together, this is a slightly different version of the prototype, was this very small talky inspired environment that I showed last year in the keynote in Splash. You can go look at more of it there and learn about the thoughts behind it. But this was pretty cool because it kind of mixed Excel and like I said, something like Self, and then a calculator-like interface that you could imagine actually just doing on an iPad. This was really neat. You could build really cool stuff with it. While we were at the cabin, Corey used a Kinect and had it hooked up so that he could drive his remote control car by pretending like he was holding a wheel in the air on this thing. It was neat stuff. But this wasn't quite right either. This was very clearly programming. It wasn't living up to our actual goal. And so we gave it one last effort. This is towards the end of 2017, right? And we were pretty much running out of money. We had about, I think, 6 to 8 months left at this point. And we realized I had written this essay years ago about how programming isn't what matters, it's modeling that matters. And so, okay, let's reframe things. Let's make it something that somebody like my wife's mother could use. What would that look like? And we ended up with this tagline, you give us the model, we give you the interface, we give you the rest of it. And we built this very cool version of
work the way a person does. We don't write a bunch of incantations in a term.
So we built this really cool version of Eve that we never released publicly. You guys are the first to see this. Where it really was, you gave us a model, and we wanted to do it on a phone because a lot of people, that's their primary computing device these days. And you could actually build your entire business software in a minute and a half in this thing. It was really, really cool. So I had actually built the software that ran my wife's family's business, and we replicated it in here in this video, which ends in 50 seconds. That was really, really cool. And so we used this and we started showing this around to potential acquirers going, hey, here's a thing that could be a product. It's the culmination of a bunch of work that we had done over the years. This is exciting. Aren't you excited, right? People were actually excited when we talked to them, but nobody was interested in trying to productize something like this. Despite that fact, I spent the last 3 or 4 months of 2017, the beginning of 2018, just going around talking to acquirers. And there were lots of people very interested in us, and all the crazy skills we had developed on building weird databases and stuff, but they weren't interested in Eve. And so, unfortunately, at the beginning, 2 days before my birthday, I put out this post to say that Eve was winding down. And this is the point at which I must say our community throughout this entire process was absolutely amazing. When we put this up, we got so many messages from people saying how much that our work had meant to them and how it had inspired them and so on and so forth. And this was really important because this was a downtime, right? Like this was a rough period. But it helped remind us that we had built all these crazy things that, we had done an insane amount of work. And we had built 34 environments and 24 compilers and 9 interpreters and all these crazy things as four guys in a tiny little office who didn't know what the heck they were doing half the time. And our bibliography at the end of this was between 500 and 600 papers long. Boy, had we come a long way. But there was a lot more that we could still do, and I promised Jonathan that I would talk a little bit about the opportunities that could come after this, where we saw there were things you could still do, or where we would actually start to look. And I really truly believe what I wrote in that essay about modeling, which is I really do believe that modeling is where you should focus. That, like, one of the things, that example that I gave was crazy. We had never built anything else like it. Being able to build the entire business architecture that you have in a minute and a half on a phone was a huge, huge result. And I think it really comes down to stop programming, help people model. We should be building modeling tools. Similarly, like I said, this is the crux. If somebody can figure out how to make it so that every single action you take provides you value, you will win. This is ridiculously hard, and I'm dramatically reducing it here, but like, if you do this, you win. Another thing that we think is a huge opportunity is that in 0.2, we gave you the ability to ask questions about your software. The ability to say, why isn't this what I expected it to be? What is this? How did it come to be? All of these things. This is a huge opportunity to just crush programming as it exists today. When we worked in this system in 0.2, debugging took seconds because it literally was, the system told you exactly what was wrong. We need this. This is a thing that must exist. And then lastly, shouting out to Frank again. This is a fantastic and hilarious paper. You should go read it. We have a guy who is beating state-of-the-art systems at very famous conferences with his 5-year-old laptop. We have not actually done a lot of the right work here. There is a ton of opportunity to improve. Okay, so those are sort of the opportunities that I would go chasing. And as a matter of fact, I'm still working on the modeling stuff now. But as a sort of an outro, I told you this story, and I'm not going to lie. There were times when it was pretty intense. We did a lot of crazy stuff, and it was a pretty tough thing. But it was an absolutely amazing and life-changing ride for us. And so, to everyone who believed, thank you.
Chris again for everything he's done. It's inspirational and sobering, but I hope we can all pick up from this and continue forward. And I hope that you're part of that path in the future as well. So let's thank him again. All right, so our next speaker is